In this lesson, we will explore the fundamental rules of exponents and apply them to simplify expressions. So before we can start looking at the exponent rules, we want to remind ourselves, what is an exponent? An exponent refers to the number of times a number is multiplied by itself. So we see here expanded form, a is being multiplied by itself many times. Okay, so expressed at exponent form, the number or term being multiplied by itself is considered the base. So in this case, we have a as the base, and the exponent would represent how many times a is being multiplied by itself. It's hard for us to tell in the expanded form, so we're just going to use n as the number of times it's being multiplied by itself. So again, a would be our base, n is our exponent. Okay, so remember, this is repeated multiplication. So let's start with the product rule. The product rule tells us when we multiply powers with the same base, we add those exponents. And again, this only applies if the bases are the same. Okay? So looking at 5 to the exponent of 2 times 5 to the exponent of 3, we would keep the base and we would add those exponents. So 2 plus 3 would be 5 to the power of 5. Okay? To evaluate that, we would take 5 to the exponent of 5, which would be 3,125. Remember, it's not 5 times 5, it's 5 times 5 times 5 times 5 times 5. So when 5 is being multiplied by itself 5 times, evaluating that would be 3,125. The quotient rule. The quotient rule is used when you divide powers with the same base. In that case, you would subtract those exponents. So 7 to the exponent of 5 divided by 7 to the exponent of 2, we'd keep the base. You always keep the base and simplify by subtracting those exponents. So 5 minus 2, which is equal to 7 to the power of 3. If we took 7 times 7 times 7, meaning 7 multiplied by itself 3 times, that would be 343. Power of a power rule. If you have a power to an exponent, you would multiply those exponents. So again, you keep the base. So in this case, the base is 3 to the power of 2. All to the power of 3 means we're going to take 2 times 3. 2 times 3 we know is 6. 3 to the power of 6 means 3 multiplied by itself 6 times would result in the value of 729. Okay, extending this rule is power of a product rule. So you have two product means two bases are being multiplied, a and b, all to the power of n. You would have to distribute that exponent to both of those powers. Now keep in mind, if there is an exponent that is not seen, it is never 0 because there's a separate exponent rule, which we look at in a little bit. We have to take that exponent outside of the bracket and multiply it to both of those exponents inside the bracket. So a hint is, if you don't see an exponent, make sure you put the number 1 there to remind yourself to properly simplify and apply those exponent rules. So because it's a power of product rule, we're going to take that 4 and we're going to multiply it to both of those exponents. So this would become 3 to the power of 4 times 2 to the power of 4. Okay, in this case, because those bases are not the same, so it's 3 to the power of 4 times 2 to the power of 4. Those bases, 3 and 2, are not the same. So there's nothing else we can do here in terms of our exponent rules. However, we can simplify. We know 3 to the power of 4 is 3 times 3 times 3 times 3, which would be 81. 2 times 2 times 2 times 2, we know that is going to be 16. And then we know 81 times 16, which is 1,296. Power of a quotient rule, same idea. If we have a power to an exponent, we do have to make sure we distribute the exponent outside the bracket to each of the exponents inside the bracket. So we have two powers here, a to the power exponent of 1 and b to the exponent of 1. We have to make sure we distribute. I'm going to show with arrows so we don't overlook that, because often that happens. So if you don't see an exponent, we know it's 1. So we want to make sure we distribute properly. So this becomes 2 to the power of 1 times 2, which is 2, over 5 to the power of 1 times 2, which is 2. Then simplifying, 2 to the power of 2 is 4. 5 to the power of 2 is 24. All right. Winding down, we have negative exponent rule. In order to make a negative exponent positive, you take its reciprocal. So again, any fraction any whole number that does not have a fraction is always over 1. So when you flip that, so basically what's happening is what's in the numerator comes down to the denominator and then vice versa. So in this case, we have 3 to the exponent of negative 2. That would be over 1. If we take its reciprocal, we take 1 over 3. And by taking its reciprocal, the negative exponent becomes positive. So that negative 2 becomes a positive 2. Notice the base stays the same. It does not impact the base. The value of the base stays the same. It's still positive 3. 3 to the exponent of 2, which would be 9. So that would be in simplified exponential form. And that would be evaluated. If, however, you have a fraction to start with as your base and you have a negative exponent, by taking its reciprocal, you're basically just flipping. The numerator becomes a denominator, the denominator becomes a numerator, the exponent becomes positive. So you've taken that reciprocal. So in this case, we would take 3 over 2, take the reciprocal. That means the exponent becomes positive 2. Keeping in mind, like I mentioned before, any base that doesn't have a visible exponent, it is not 0, it is 1. So we're going to expand and make sure we multiply both of those exponents by 2. So it becomes 3 to the power of 1 times 2, which is 2, and 2 to the power of 1 times 2, which is 2. 3 squared we know is 4, 2 squared we know, 3 squared is 9, 2 squared is equal to 4. And last but not least, we have zero exponent rule. That rule tells us any base to the power of 0 is always going to equal to 1. So base of a to the exponent of 0 is equal to 1. Your base can be any number, it just cannot be 0. So in this case, we have 3 to the power of 2 divided by 3 to the power of 2. So in this case, we are using the quotient rule because we're dividing powers with the same base. They both have a base of 3. We can take 3 to the power of 2 minus 2. Well, we know 2 minus 2 is 0. To evaluate 3 to the exponent of 0, it will equal to 1. Okay, let's evaluate the following using all the above reviewed exponent rules. So if negative 5 to the exponent of 2, remember this is repeated multiplication, so it's negative 5 times negative 5. Negative 5 times negative 5 is positive 25. Now B, notice the base is actually negative 1 times 5 to the power of 2. Because the negative, as in example 1a, was not in brackets, the base in A is negative 5. However, the base in B is not. It's negative 1 times 5 to the exponent of 2. So I'm going to show it expanded. But that just means it would be negative 1 times 5 times 5. And as you can see, your final answer is not going to be positive this time. It's going to be negative 25. Okay, so you got to be careful with that. If the base is negative, it would all be in brackets. If it's not, that means it's negative 1 times that power of 5, base 5 to the power of 2. Looking at C, we're multiplying powers with the same base. We're going to keep our base and we're going to simplify by adding our exponents. Negative 6 plus 5, which is 6 to the power of negative 1. Again, we want to always express all powers with a positive exponent. So keeping in mind that's like over 1. So we're going to take the reciprocal, it becomes 1 over 6 to the power of 1, which we simplify as 1 over 6. Excellent. Okay, looking at D, we're multiplying powers with the same base. In this case, the bases are negative 1 over 5. Notice that's in brackets, so the base is negative. We're going to keep that base. And we are going to, because we're multiplying powers with the same base, we're going to add those. Oh, look at me, silly me. Look at me, even with my glasses, I didn't notice that the bases are not the same. So in this case, there's nothing we can do except for just evaluate them. So if we have negative 1 over 5 all to the power of 3, that's going to be negative 1 to the power of 3. So in this case, we can't use any exponent rules. We're just going to do 5 to the power of 3 times, and bring that negative 1 to the power of 2 all over 2 to the power of 2. Okay, so it's going to be negative 1 over 125 times 1 over 4. Okay, so negative was, remember, when you multiply fractions top with top, bottom with bottom, this becomes negative 1 over 125 times 4, which would be, well, let's double check that. I think I want to say 500, but double check. Yep, 500. And there we have it. Okay, moving on, we have, again, bases are not the same. So we can't apply any of the exponent rules, but what we can do, because we're taking a power plus a power, again, no exponent rules apply because the bases are not the same. And there really is no exponent rule for adding two powers. Okay, so let's first deal with the negative exponent. So we have a negative 2 over 3 to the power of, or to the exponent of negative 1. We're going to take its reciprocal. So this becomes 3 over 2 all to the exponent of 1 plus 5 over 2 all to the power of 2. Notice we took its reciprocal. Okay, so negative exponent rule tells us when you take its reciprocal, the negative exponent becomes positive. Because the base was already a fraction, we can just flip. Okay, take its reciprocal. So this becomes 3 over 2 plus, here we can use power of a quotient rule. So we're going to take 5 to the power of 2, which is 25, 2 to the power of 2, which is 4. And then, of course, when you're adding fractions, you have to have a common denominator. In this case, it is 4. So we're going to multiply numerator denominator by 4. And this becomes 6 over 4 plus 25 over 4. We keep the base, add the keep the denominator, add the numerator, 6 plus 25, which is 31 over 4. Okay, that's an improper fraction. We could put this into mix. 4 goes into 30, let's say 28 times. Sorry, 4 times, sorry, 7 times. So it's 28 over 4, 28. The remainder would be 3. Okay, moving on, we have apply the exponent rules to simplify the following. So notice the bases are not numbers, they are variables, but you still apply the exponent rules the exact same way. When you're multiplying two powers with the same base, in this case, both are x's and 2a, we're multiplying them, reminding ourselves that that dot means multiplication, for those of us who maybe didn't know that. We use that often because if we had an x in there, it'd be confusing with the powers. So in this case, we'd keep the base, add the exponents, 5 plus 2. That becomes x to the power of 7. Okay, dividing powers with the same base, you keep your base, subtract your exponent according to the quotient rule. So this becomes y to the power of 4. Power 2 power, you keep the base, multiply your exponent, 2 times 3. This becomes a to the power of 6. All right, again, keeping in mind power of a quotient rule, you have to distribute. So this becomes x to the power of 1 times 2, which is 2, y to the power of 1 times 2, which is 2. You cannot use the quotient rule here because the bases are not the same. X and y do not have the same base. Okay, expanding here, we have x to the power of 2 all to the power of 2. So we're going to multiply those exponents. So it becomes x to the power of 2 times 3, which is 6. Keeping in mind, again, if we don't see an exponent, it is always 1. That silly mistakes happen when we overlook that. So this becomes 2 to the power of 1 times 2, which is 2, x to the power of 1 times 2, which is 2. So this becomes x to the power of 6 all over 4x to the power of 2. keeping in mind we are now dividing powers of the same base, so we can use that quotient rule. So it becomes 1 over 4 x to the power of 6 minus 2. Well, 6 minus 2 we know is 4. So 1 over 4 x to the power of 4. Excellent. Okay, so let's make it a little bit busier, but we're still, even though it looks a little bit more complicated, we are always following the exponent rules. So keep in mind, BEDMAS must be followed with anything you do in math. So the first thing we always want to do is check our brackets. Inside our brackets, is there anything we can do to simplify? Okay, and again, applying our exponent rules in there as well. So if you see here, we have always include those exponents. We're multiplying those two together, so the bases are the same. We have x's, two x's being multiplied, two y's being multiplied. So we're going to say x to the power of, well, 2 doesn't have anything, so we're going to say 2 to the power of 1, x to the power of, and I'm just going to, because I can, highlight these powers. Okay, and you're multiplying them, so we would add those exponents. So 3 plus 2, which would be 5, and y to the exponent 4 plus 3, which is 7. And that is all to the power of 2. Okay, so now we have power to power. Okay, don't forget, you must always follow BEDMAS. I know put that in words, but I'm going to remind you by writing it up here. We worked in the brackets first before the exponents. Now that we've done that, this becomes 2 to the power of 1 times 2, which is 2, x to the power of 5 times 2, which is 10, y to the power of 7 times 2, which is 14. 2 to the power of 2 we can simplify, so it's 4, x to the power of 10, y to the power of 14. Okay, again, here we have in B, we're going to simplify the denominator first before we do anything with the numerator. There's nothing we can do in the numerator anyways, but before applying that quotient rule, we're going to simplify what we have in the denominator. So the whole number is 3 and 4. We can't apply any exponent rules, but we can multiply them. 3 times 4 we know is 12. We're multiplying two x's together. So we can add those exponents. So 3 plus 2, which is 5. And then we have y to the exponent. So notice I put in that exponent of 1 to remind myself, even though nothing's there, we know it's a 1. So 1 plus exponent of 3 there. So 1 plus 3, which is 4. Okay, once we've simplified that, now we can try to use our exponent rules using that quotient rule. When we divide powers of the same base, we subtract their exponents. Keeping in mind, we are able to simplify 2 over 12 is the same thing as 1 over 6, so we can reduce that. Okay, and then we have x to the power of 7 minus 5, which is 2, y to the power of 5 minus 4, which is 1. We don't have to actually include that one, but we know it's there. Okay, looking at C. Again, always following BEDMAS, we're going to simplify everything in the brackets first before we take it to the exponent of 3. So again, when we're multiplying powers with the same base, we add their exponents. Okay, reminding yourself to put in those exponents of 1 because even though we don't see anything, we know it's a 1. So we can say 2 to the power of 2, or we can just multiply those. 2 times 2, which is 4. M to the power of 1 plus 4, which is 5. N to the power of 4 plus 4, which is 8. All over m to the power of 1, n to the power of 4, all to the power of 3. Again, we still need to follow BEDMAS and simplify what's in the brackets first. Using our quotient rule, we can divide powers with the same base. So this becomes 4 m to the power of 5 minus 1, which is 4, n to the power of 8 minus 4, which is 4, all to the power of 3. Okay, so keeping in mind, even though we took 2 times 2, that power, we're not done yet because we have to take that whole base, all those, everything in the brackets, all to the exponent of 3. So I did that to remind ourselves that all these exponents get multiplied by 3. So this becomes 4 to the power of 3. M to the power of 12 and n to the power of 12. Well, 4 to the power of 3 we know is 64, m to the power of 12, n to the power of 12. Okay, so again, before you use the quotient rule, see if there's anything we can do within the numerator and the denominator separately first before we apply that quotient rule. So if we look here, we have 3x cubed y squared divided by 4y to the negative 2 times 3x to the negative 2 y to the negative 4. So again, we're going to simplify by saying 4 times 3 we know is 12. Let's keep that numerator. So we have 12 x to the power. If we took negative 2 plus negative 2, that would be, negative 2 plus negative 4, I meant to say. For y, there are no other x's, which would be negative 6. Okay, so now that we simplified that, we can apply that quotient rule. Again, 3 and 12, they're not the same base. There's no exponent rules we can apply, but we can simplify that. 3 over 12 is the same thing as 1 over 4, because we could divide both 3 and 12 by 4. Then we're going to take dividing powers of the same base. You subtract their exponents. 3 minus negative 2. So keep that in mind. 3 minus negative 2, those two negatives become a positive. So it's 3 plus 2, which is 5, and y to the power of 2 minus negative 6. Those two negatives become a positive, so it's 2 plus 6, which is 8. Okay, so again, always following BEDMAS with start with brackets first, and next would be exponents. So we would have to take and simplify that first. Okay, we also notice it says v to the exponent of 0. Well, we know v to the exponent of 0 is equal to just 1. Okay, so any power multiplied by 1 is just itself. So we can just cross that out right away so that we have that dealt with. Then we're going to keep 2u to the negative 2v3. This becomes, and I'm going to show multiplication by just giving those brackets. It's going to be 2 to the power of negative 1, u to the power of negative 1, and v to the power of negative 4. All over 2u to the negative 4. Okay, so keeping in mind, if there's no exponent, we're going to put that in there, only because both of those bases are the same, 2 and 2. So we can use the product rule here. When we multiply powers with the same base, we can add those exponents. So this would become 2 to the exponent of 1 plus negative 1, which is simply 0. U to the exponent of negative 2 plus negative 1, which is negative 3. V to the exponent of 3 plus negative 4, which would be negative 1, all over 2 to the exponent of 0, u to the negative 4. Okay, when you divide powers with the same base, you subtract their exponents. So this becomes 2 to the exponent of 0 minus 1, which is negative 1, u to the exponent of negative 3 minus negative 4. So watch your integers. That becomes plus 4, which is 1, and then v to the power of negative 1. Now, we always want to express our final power with positive exponents. So we know we can take the reciprocal of both. Okay, so this final expression will be u over to the rest of the negative 2 to the power of 1 and v to the power of 1. Excellent. Okay, last but not least, again, always following BEDMAS. That means we have to simplify everything in the brackets first before we can take it to the exponent of negative 2. So looking in, even within the brackets, we follow BEDMAS. So keeping in mind, we would have to deal with that power here first before multiplying each of them. Okay, so again, you really want to make sure you're following BEDMAS throughout. So this would become, we're going to say 2 to the power of 1 times 3, which is 3, x 3 times negative 3, which is negative 9, y to the power of 0, and z to the power of negative 3, multiplied by x to the negative 3, y to the 2, all over 2, x to the power of 3, all to the power of negative 2. Okay, so again, remember this means multiplication, so we're multiplying those two powers together. Any bases that are the same, 2 to the power 3, no. But we have x to the power of negative 9 times x to the negative 3, adding those together, negative 9 plus negative 3, which is negative 12. Y to the power of 0 plus 2, which is 2. And then z to the power of negative 3 all over 2x cubed all to the power of -2. Okay, now we're going to use the quotient rule. Again, we follow BEDMA, so we have to simplify the bracket completely before taking it to the exponent of -2. So in this case, we would have 2 to the power of 2, 2, 3 minus 1 is 2. Keep those bases x, so it would be -12 minus 3, which would be -15. Y to the power of 2, z to the power of -3, all to the power of -2. Okay, so we've been simplified the brackets fully. Now we're going to take it to the power of -2. So keeping in mind, if you don't see an exponent, you put it in there because that -2 has to be distributed to each of our exponents. Okay, so power to a power, you multiply those exponents. So this becomes 2 to the power of 2 times -2, which is -4, x to the power of -15, which is times -2, which is positive 30, y to the power of -4, and z to the power of positive 6. Okay, so again, any of those negative exponents, in order to make them positive, you have to take the reciprocal. So this would become x to the power of 30, z to the power of 6, all over. So take those reciprocals, and they just become part of the denominator. So 2 to the power of 4, y to the power of 4. Simplifying would be x to the power of 30, z to the power of 6, all over 16, y to the power of 4.